This is the second episode, and this time we're reviewing a kanna that I bought from Chuk. Now this package contains the kanna itself, which has a width of 65mm, while the other item is a hammer. The hammer is used for tapping out the iron. So in this episode, I will be reviewing it and also tuning the kanna in order to be usable. It is said that this kanna is 40 years old, so let's see how this goes. This is the hammer. It's about 450 grams steel hammer. Next item should be the kanna. Red oak. Package but with wax. Before he sold it to me, he did warn me about this. I didn't really bother about that. Anyway, I can tap it out again with the newly acquired hammer. As to be expected, some rust. No big issue though. You can clean it up easily. Kanna's fantastic. Pretty sharp. Need some rework, but overall, a bit fantastic piece of hardware. The maker's mark. Maker's mark. You definitely need some work to get it back to condition. First of all, let's get the rust off. Second would be to this cap iron. Not bad at all. So we have the blades. The die. The die is in good condition. Some knots here, as you can see. Some knots here too. And knots here. But the sole has some knots through. They're not in the mouth. Some interlocking grain, but still a very functional blade. So the next video is to tune this, remove the rust, and these two, and sharpen the plain iron. So let's see how this goes after this. Okay, we're gonna continue on with this. Alright, here's the blade again. As you can see, it's pretty rusted. They are going to remove the rust with a handheld sandblaster. Sometimes this is called air eraser. We are going to use baking soda. Baking soda is over here. So what we're going to do is we're going to put this powder form baking soda, as you can see, into the container, and this is going to be shot at about 50 psi onto the rust. So let's see how effective this is going to be as it is right now. This is a zoom up of the current item that is being blasted, the chip breaker. This is going about 50 psi using carbonate soda. I just tried the aluminum oxide at 80 grit. Here's the aluminum oxide that I have loaded into the sandblaster. At 80 grit, it definitely does remove the rust. As you can see, the blade rust has been removed. But now here's changed it to some metal that I need to repolish. I will do it for the remaining of the blade as it is, and here's the process that I will share with you. Here's the process as it is. I hope you can see it. As you can see, the tip has been removed. The rust has been removed at this point. And this is what I'll do for the remaining of the plate. It's quite fast actually. I guess I'll do it here. As you see, it's easily removed, the rust. I'll do it for the remaining of the blade. Hopefully it does not take off too much of the patina. So this is the final outcome of the blade. The rust majority has been removed, but as you can see, it's not perfect. I think the best step is still to use chemicals. Let's see how this one goes. This is where I'm going to use this chemical to remove the rust. Hopefully that works better now. Here's the close-up of what I'm going to do. As you can see, the plain iron is pretty oxidized. I'm going to let it react for the next few minutes. Once the reaction is completed, I'm going to remove the plain irons out from the chemical solution. Stop the reaction. Looks like it's working pretty well and pretty fast. You can see the bubbles is forming onto the metal itself. So let's wait for a while. So this is what happens when the patina is removed. I'm going to leave the result because I want certainty that the metal is properly treated. As you can see, the acid is definitely much better. Sandblasting is okay, but I'm not very confident with its result this one. Anyway, I think once this is done, along with this plain iron, I will sharpen it and definitely polish out the bits and pieces. Like this part is a bit, there's a lot of shiny part. Look at this. Yeah, the one on the string here is lots of shiny part. So let's see what goes on after this. This is going to be the next step, as it is. After removing the rust, you will now need to sharpen the blade, as it is. I intend to use waterstones, sharpened, starting from 2000 all the way to 8000. After checking the blade, I noticed that the blade isn't too bad a condition in terms of sharpness, so I can start with 2000. If the blade was thick, I'll definitely have to grind at a much higher and it's a much lower grade, like 120. But in this case, the blade, as you can see, is pretty good, so I will start with 2000 and move all the way to 8000. I also need to sharpen the chip breaker at this side, not too much. It's just to get it leveled out as I place the chip breaker to the blade itself. So I want perfect contact between these two areas here, as you can see. I definitely want perfect contact between these blades. This is what I'm aiming for. So here's the process, and I'll document the steps as I go through. So this is the final product of it. I have yet to test it with paper. I'm going to use paper to test it for the sharpness. It's a paper test. Oh yeah, this is paper. Okay. Yeah, be sharp. Be sharp, be sharp, be sharp. It's really sharp. I think with the finger test I can test more. What I do, I run my finger over this, my nail, like this. Alright, so there's one portion here that's been, there was a rust spot. So, in due time this part will be removed, so I'm not really worried about this. There's no point to grind all the way back just for that little spot. Majority of the plate. So here's a bit rough. Here's a bit rough. For the rest, silky smooth. Cool. I'll take off my nails with ease, as you can see that. I'm not sure if it's catching on camera. Oh, did. Oh well. Nice. Okay, so here's the plain iron. that's been sharpened. After this, I need to tune the kanna's body. On to the next task. Here's a chisel. This is the most time-consuming part of the tuning. Is to get the bed correct. When it first came in, it was hardly passing through the mouth, so I had to use a chisel 138 and pare down this section here. The looks of it, there are some chisel marks here, but I'm going to keep it as it is, because if I do a slight tuning, I may just get it off center again. So I mean off center means in the natural position when I tap it, that is, when you look at this point, it should be even as it is. So that's something that you need to be aware of. Do not move too much material. So again, drop it in there, and that should be the case. So once that's done, you know that the blade is fully seated. There's no rocking. Okay, so here's one part that you can break off, turn it side to side to get release again. And this took a long time. It probably came out to about this amount of shavings at the end, probably 2 to 3 times more of this, but that's the amount of time you need to take to tune it. What I use to tune is that I put a camellia oil on top of it, wiped here, fit it in, saw the high spots, remove the chisel. Continuously doing this over and over, repeating the process until I got the blade protruding edge putting out of the mouth. So it's not right protruding out like 5 millimeters. It's really small. The depth is probably about 1.5 to, I think maximum depth is about 1.5. So that's the tuning I did over the bed. There was also some relief that I have to put over here. So that was this preventing the blade from being positioned well enough. After that was done, I noticed that the edge of the blade was too close to the mouth, and when I took shavings, it just jammed the mouth. When the shavings get jammed, what I suggest is that you take probably a diamond file like this, 80 grit, and file it down here. Chuk uses a chisel, but I use a file. Doesn't really matter as long you're able to control the amount of material you remove here. So when that happens, you will probably get about a gap of 1.5 millimeters as it is from this angle. As you see down the mouth, you probably get 1.5. Now, with the bulk of the time we're tuning the bed, opening the mouth a bit, I probably moved about 0.5 millimeter out of here, not even a millimeter. And we had and that's about it actually. And then the body is something that needs attention. I'll describe it later. So the next step as it is to determine whether the body is flat. This is highly important from Western plane to Eastern plane. In this case, it's kanna as a Japanese. What I do is that I generally use a straight edge. Yes, this is a wooden straight edge, but I'm pretty confident it's straight, as I have another reference somewhere in the house. What I do is generally I do this, and I see no light coming out from here. So what you want is totally no light coming out as it is from here As you can see, I'm angling between this section to this section, and finally seeing this section. So with that said, now I have determined that the plane is straight. There are two configurations that the Japanese does, one of which is to use the following. So this is the configuration of the sole. Japanese generally use this configuration when it's convex. Before the this is before the plate and after the plate for shooting and then smoothing. What we have determined from the straight edge is that it's like this, straight. Now, it's not generally accustomed to use this, but here's the thing. I don't see any downside using this configuration as it is. There is no harm using this, nor this, but why not this? In the Western plane, as we know it, is similar in this concept. Okay, we do not use this concept. Now, to remove, as in a metal plane, it is perfectly acceptable to use a plane like this. So I'm going to use the Western way of determining the sole of the plane, which is straight edge, which I demonstrated just now, and with the sole configuration of a Western plane, if it's straight. Generally, some Western planes are in this configuration or this configuration. I'm going for this. I'm going to skip this this thought of a kanna plane that needs to be of this configuration for smoothing. So that being said, this is my choice. So here's the plate configuration that I got to. Shooting, I use straight right angle. Western planes, I generally smooth with a rounded edge. This round, the kanna, as a camber, the 132. I'm not generally accustomed to this. I believe this is better, but looks like this works well on the kanna itself. I left it at this configuration instead of moving to this because to remove that much material on a kanna makes it extremely hard due to its hardness of its the blade itself. So I'm going to leave it this first. As time passes by, if I don't feel it's right, I'll move on to this with a round edge. So let's see how this works out in the long run. Anyway, the shavings coming out from this is acceptable. So this is going to be a demonstration on the plane after it's been tuned. The sole is straight as it is. I have demonstrated with a straight edge, and on top of that, plane iron is sharpened. It's been installed with the chip breaker. As I've said, I've broken some norms. I have not ensured that the dimension here is a bit of a hollow between this section to all the way to here and here to here. The reason that I mentioned is that I have not used the traditional setup. Is that, to my understanding, a straight means straight. It does not mean I need to hollow it out. Yes, there is less contact surface, but that's not the point. The point is, as long as it's able to contact the wood, it's good enough, and it does not jump or ride upon the bumps on the wood. So that's what I intend to use. That's what I understand. That's why I use it. On the iron, if there's a hollow, but there are contact points here and here, and just before the mouth and after the mouth and here, it's good enough. But for some reason, I still cannot comprehend why the Japanese decided to put a hollow here and here all the way to the end. So this is beginning and this is the end. I'm not too sure, and I don't really understand the rationale behind it. I will demonstrate on a piece of pine and Meranti to show you what it's capable of. I set it to as fine as I could get it to be, but still it is it's how you tune in, no, how you set up the plane. As you tap it in, tap it out, to a point it works. So here's the pine that I'm going to play. As you can see, the shaving is very thin. Not as thin as Chuk, but because due to the depth of the blade. But it's thin, very thin. I'm not sure. I'll have to check with a micrometer or something like that. But it's super thin. The next step is going to be Meranti. So this is yellow Meranti. This was white pine, as you can see. Again, the grain direction is very important. Hardly any resistance. Again, depending on the type of wood. This is the thing. It's a long shaving. It's from all the way from one end to the other end. Hardly any issue though. I think the weight of the plane helps. The weight of the plane definitely helps. The setup definitely does too. So I'm impressed. I'm definitely impressed with the outcome. So thanks to Chuk for selling me this plane. Was it a worth buy? I think so. It's definitely a good plane. After the tuning, only after the tuning, not before. Before I had to sharpen. Again, what did I have to do? I had to sharpen the irons, remove the rust, fix the bed of the plane, open the mouth a bit. The body I found out to be straight, so there was no bumps, all the contact points were right here, all this was straight. No cracks in the plane. Nothing could be done for that if that happened. So overall, after those tunings, and don't forget the slide gap, you can see. Okay, you can see there's a slight gap at the mouth. There's a slight gap at the mouth. That's how you control the tear out if it is to occur. So this ends the second episode that I've done. This is definitely a keeper. Thanks.